Section 9.2, Measures of Variation. One of the most useful means of data is determining how far away our numbers are from the mean, also known as the standard deviation. So how far numbers are away from the mean is also known as standard deviation. So find the range, variance, and standard deviation of the following numbers. So in order to find standard deviation, we automatically find its variance. Standard deviation is just one step further once we find the variance. We can find the range. Range really has not much to do with standard deviation, but it's part of this section. So the range is taking the highest number and subtracting the lowest number from it. So our range in this example is 40 minus 7, so 33. We also need to find the mean. Mean is part of the formula, so we need to find the mean of all these numbers. So we're going to add them up. We have 8 numbers, so divide by 8. So if I add them up and divide by 8, we'll get 23. And we're going to need to come back to that. So now how we find variance. So we have our numbers, and we're going to call them just a random x. And then we're going to take those numbers and we're going to square them. So 7 squared is 49, 9 squared is 81. And we need to add all of these numbers up. So all the squared numbers up. And when we add them all up, we get 5,132. So the formula for finding variance is represented by s squared, is variance. It is the sum of our x squared numbers minus how many total numbers we have multiplied by the mean. So this little mu here is the mean. Square it all over how many numbers we have minus 1. So the sum of x squared would give us the 5,132. So this little e looking thing is called the sum. So we want to add all of our x squareds together, so that's 5,132 minus, we have 8 numbers all together, so that's our n, multiplied by the mean, so this is the mean, which is 23, and then we square that all over how many numbers we had, subtract 1. So this is equal to, now just using the order of operations, 5,132 minus 8 times 529 divided by 7. And if we multiply, subtract, and then divide, we'll see that it is equal to 128.57. So here's our variance. Finding the standard deviation is just one step further. So the standard deviation is simply taking the square root of whatever number we got from the variance. So the standard deviation of this set of numbers is 11.34. Find the standard deviation for the grouped data below. So this is the same frequency chart that we had in section 9.1. So we're just I'm going to transform some numbers from that table to here. So we had our midpoint. So if you want to pull out the chart that we had created, we had 2, 7, 12, 17, 22, 27, and 32. Now we need, since the midpoint is the numbers that we're really going to work with, so we're going to label our midpoint is going to simply be x, and then we're going to take our midpoint numbers and square them. So 2 squared is 4, 7 squared is 49, and so forth. So we'll just continue writing our numbers here. All right, but we can't quite stop here. That we can't just start finding the variance at this point, because we need to take into consideration the frequency. So I'm going to multiply each x squared by its frequency. So just kind of going straight across here. So the numbers that we're looking at are, well, 3 times 4 is 12. 4 times 49 is 196. And then just keep going down the list. So these are the particular numbers that we're curious about. And now if we add these numbers up, we get 9,015, and that's the number that we're going to use for the sum of x squared. We also found from the previous chart that the average, the mean, was 15.5. So again, to find variance, our formula is s squared equals the sum of our x squareds minus how many numbers we have times the mean squared, all over how many numbers we have minus 1. Remember also we had a total of 30 different frequencies, so that will help us here. So the sum of x squareds was 9,015. The numbers that we have are 30. The mean was 15.5 squared over 30 minus 1. So using the order of operations here, we'll have 9015 minus 30 times 240.25, so 15.5 squared over 29. So this is equivalent to 9015 minus 7,207.5 over 29. Subtracting and dividing, we get 62.33. So that's our variance, and now to find the standard deviation, all we need to do is take the square root of the variance. So 7.89. Since 1916, Nathan's Famous Hot Dogs has held an annual hot dog eating contest in which each contestant attempts to consume as many hot dogs with buns as possible in a set time period. The following table contains a list of each year's winners since 2000. In what percent of the contest did the number of hot dogs eaten by the winner fall within 1 standard deviation of the mean number of hot dogs? And how about within 2 standard deviations, within 3 standard deviations, etc.? So I'm only going to focus on within 1 and then within 2, and then you'll kind of see the pattern happening. So first we need to find the standard deviations. These numbers are going to get kind of big, so be patient with yourselves with your calculator. Double check your adding, etc. When we do this. So we need to find the mean, because we know we need the mean when we find standard deviation. So if I add all of these numbers up, and I divide it by the 15 that are there, so I have 833.375 when we add them up, divided by 15 gives me 55.6. Okay, so this is represents our x. Now we need to find x squared, meaning I need to take each one of these numbers in the column and square it. So x squared. So this is where the numbers get kind of big. So 25.125 squared is 631.27. And then just kind of go down the list. 50 squared is 2,500. So I'm just going to take a moment to write down what all these numbers are squared. Please verify using your calculator. Whew, that's a lot of numbers. And now we know that we need to add these because we need the sum of x squared. So if I add all of these numbers together, we get 48,141.08. And this should be a 4 here. Looked like a 1. Okay, so now we can go ahead and start finding the standard deviation. But first we need the variance, like a 2-for-1 special. So we want to take the sum of x squareds, which was that 48,141.08, subtract the number of items we had, which is 15, times the mean squared, all over the number of items we have minus 1. So now using the order of operations here, we'll simplify a little bit. 55.6 squared is all divided by 14. So multiply, subtract, and divide, and we will see that the variance is 126.48. Now, the standard deviation is just to take the square root of that number. So the square root of that number is about 11.25. So depending upon how you rounded during this step, and depending upon how many numbers you put here, you could have a slightly different number than I have here. But it should be about the same. Now we want to talk about one standard deviation. So to do that, I'm going to take my mean and add one standard deviation, and then take my mean and subtract one standard deviation. How many of our numbers fall, of the 15, how many of them fall within this range? So how many fall between 66.85 and 44.35? So if I look at the numbers that fall within that range, 50 does, 50.5, 44.5, 53.5, 49. So all these numbers I'm highlighting fall within that range. So there are, if I counted them up appropriately, 11 out of the 15 fall within one standard deviation. So about 73%, since it says 0.73, it's 73%. So how many fall within two standard deviations away? Well, here was one standard deviation, so now if I take those numbers and add another standard deviation and take that bottom number and subtract a standard deviation, we'll get 78.1 and 33.1. So how many of those numbers fall within this range? So if I go back up to the top, we can now include the 68s. So now it looks everything but one falls within that range. So 14 out of 15 fall within the range. So 14 divided by 15 is 0.933. So 93.3% of our numbers fall within two standard deviations. One more thing, I counted wrong. There are 11 that fall within this range. 12, not 11. So 12 divided by 15 is 80%, not 73.3. I apologize for that error. So there are 12 of them that we had highlighted, not 11. So 80% of our data falls within one standard deviation, and 93.3% of our data falls within 2 standard deviations. So to find 3 standard deviations, we could easily add another and subtract another, and hopefully all of our data would fall within 3 standard deviations of the mean. So this concludes section 9.2, measures of variation.